My name is Dr. Yap Ban Ha, and today we are going to solve a problem from Dr. Yap Ban Ha's problem box. Let's take a look at one of the problems. This problem has made its way into one of the many textbooks that I've written. Think Mathematics. This problem is about multiplication. When a two-digit number is multiplied by a one-digit number, the answer, the product, is also a two-digit number. And the 5 digits are all different. None of the digits repeat itself. And there's no 0 among the 5 digits. So that's the problem. What are some possible equations such that the 5 digits are all different and none of them is a 0? Can you give it a go before we talk about it? Let's try. So what equations are possible? Let me try. What about 13 multiplied 4 times? Would that give me a product such that the 5 digits are different and none of it is 0? Multiplying 13 by 4 times, the 10 becomes 40, the 3 becomes 12, 40 and 12, that's 52. I suppose I can check. Multiplying by 4, I can do doubling and doubling one more time. Doubling 13 gives me 26 and doubling 26 gives me 52. So all the 5 digits are different and none of them is 0. So this is a solution. But I wonder if there are other solutions. What about 19 multiplied 2 times? Is that possible? Doubling 19 should give me 38. I can check because 19 is pretty close to 20. Doubling 20 is 40. So is doubling 19 2 less than 40? If this is correct, let me check if the 5 digits are different. They are. And none of them is 0. So this is another solution. Oh, why don't I try 12 multiplied 9 times? Would that give me another solution? The 10 becomes 90 and the 2 becomes 18. 90 and 18, oh dear, that's too big. It's not a 2-digit product. I really need a 2-digit product. So that is not a solution that we are interested in. What about 14 multiplied by 7? 10 becomes 70, 4 becomes 28, 70 and 28, that's 98. Are all the digits different? Is there a 0? And this is only 2 digits, so this is okay. It's another solution. What about 17 multiplied 4 times? 17 multiplied 4 times? 10 becomes 40, 7 becomes 28, 40 and 28, that's 68. I can check by doubling 17, that's 34, and double again, that's 68. Are all the 5 digits different? Is there a 0? Is the product a 2-digit number? So that's another solution I want. Why don't you continue from here? I noticed something interesting. I noticed that I managed to get another answer after trying 14 multiplied 7 times by switching the digits. And I got 17 multiplied 4 times. Is there anything interesting that you notice here? Is there an interesting pattern that you notice between these two equations? Oh, I also noticed that this is pretty interesting. Are you able to read my mind? To say why I think that this is quite interesting? You are right. Here I use digits 1, 2, 3, 4, and 5. We call those consecutive digits. Do you think there are other equations that make use of consecutive digits? Perhaps using 2, 3, 4, 5, 6? Or 3, 4, 5, 6, 7? And so on. Why don't you try to investigate anything that you found interesting? For example, I find using consecutive digits pretty interesting. I'm wondering if there are others. I also found pairs like that rather interesting. I wonder if you're able to find other pairs like this, and if there's anything interesting about the products in those equations. Can I leave those to you? See you next time.